Ms. McCahan, and we're going to talk about how to prove lines are perpendicular. In last class, we talked about proving lines parallel, and we had that nice transitive property of parallel lines that said that if two parallel lines are parallel to the same line, then I know that these are parallel to each other. So we're going to talk about now perpendicular lines. Here are a few theorems that talk about perpendicular lines, but they don't necessarily all say that the conclusion is lines are perpendicular. This first theorem, says that if we have two angles that create a linear pair, notice that 1 and 2 create a linear pair, they're on this line and they're adjacent to each other. And if those same two angles are congruent angles, so you see they're marked congruent, then we know that these lines are perpendicular. So notice this conclusion shows that these lines are perpendicular. And this makes sense because if 1 and 2 add up to be 180 because linear pairs are supplementary, and if those two are congruent to each other, then 1 and 2 both have to be 90 degrees, which is what we mean by perpendicular. The second theorem is saying that if we know two lines are perpendicular, then they're going to form 4 right angles. And that kind of makes sense too because of linear pairs. If we know linear pairs are supplementary and this is 90 degrees, then this one has to be 90 degrees, and this one does, and this one does. So all of those make sense because of linear pairs, and even you can use vertical angles as well to show that that makes sense. And this third theorem down here is saying that if two sides of adjacent acute angles, so 1 and 2 are those adjacent acute angles, and the two sides they're talking about are BA and BC. So if those two sides are perpendicular, and you see they are marked perpendicular with that box, then the angles are going to be complementary. And again, this should look pretty familiar since we've already talked about complementary, and this is what the kind of diagram we use to show complementary. 1 and 2 add up to be 90 degrees. This next theorem is called the perpendicular transversal theorem, and all it says is that if we already have two lines that are parallel, and we know that transversal is perpendicular to one of those parallel lines, then that transversal is also going to be perpendicular to that other parallel line. And again, that makes sense because these two angles, this box right here, and then if I drew another box right here, those would be corresponding angles, and we know corresponding angles are congruent when lines are parallel. This last theorem, though, this is going to be our most useful theorem in proofs, and it's called the lines perpendicular to a transversal theorem in our book, but you can use dual perpendicular theorem for shorthand if you'd like in your proofs. So in this theorem, if we know that M and N, these two lines, see how they are perpendicular to this same line, this line P. So if we know that two different lines are perpendicular to the same line, then we know those two lines are going to be parallel to one another. So M and N are then parallel to one another. And we know this because if these are perpendicular, they create these 90-degree angles. And so we're using the converse of that corresponding angles theorem, so cap converse. Remember we said if we know corresponding angles are congruent, then those two lines are parallel. So that's what this is using. It's just going to be a shorthand rather than going through all of those steps and saying all of that. We can just say dual perpendicular theorem. So now let's actually use this theorem. So you can see that we're trying to figure out which lines can we determine are parallel and why. So I'm going to trace some of these lines. We'll do one thing at a time. So I'll use pink. I'm going to look at these two boxes right here. Okay, so those two boxes are perpendicular to this line Q. So what that is telling me, if I use that dual perpendicular line theorem, that means the other lines that create those boxes, so that would be S and T, those two lines have to be parallel to one another. So I'm going to mark those parallel. So S and T are parallel to one another because of that dual perpendicular theorem that we just learned about. Now, if I go back to these other two boxes, I'm going to trace that line. These two boxes right here are perpendicular to this line S. So I'm tracing over that with the blue. Alright, so since these two lines that create those boxes, so that would be line P and line Q, since those two are perpendicular to this same line S, then I know P and Q are parallel to one another. So I'm going to mark those parallel as well. So we knew that P was parallel to Q, and then we also knew that S was parallel to T, all by using that dual perpendicular theorem. Now notice that we didn't do anything with U. U was not marked perpendicular to anything, so we can't really say anything about U. If we look at this one, again, I'm going to trace out the line that both of these boxes touch, and then I'm going to trace out the two lines that create the rest of that box and this box. So you can see that the two lines that will be parallel are A and B by that dual perpendicular theorem. So we know A is parallel to B. Also, I see another set of perpendicular boxes. So I'm going to trace those out. I'll do that in blue. So these two boxes both touch this same line A. And that means that these other two lines that create the rest of those boxes, there and there, C and D, those must be parallel to each other. So I could mark those parallel. So when you're using diagrams from here on out, be looking for perpendicular lines and which ones would be parallel. So we would know C is parallel to D. Alright, let's do maybe one or two more. And in this diagram, notice we're trying to figure out which lines are parallel. So we're kind of going back and reviewing a little bit. So let's just say we wanted to prove A and B parallel. I'm going to trace out A and B just so we can figure out what's going on in this diagram. There's a lot going on, so it's important that you highlight or ignore all the things that you're not using, or highlight the things that you are using. So I'm highlighting A and B, and there are a lot of transversals that cross both of those lines. I could use this transversal E or D or F or G, but I'm going to look at G because G has a lot of angles that touch G. So remember that when we pick a transversal, we want to pick angles that touch both a transversal and the parallel lines. So notice that in this diagram, I have 114 touches both that pink and green line. And then I also have angle 66 that touches both that pink and green line. So if we look at just that piece, I can see that 66 and 114, those are going to be same side interior or consecutive interior. So if I want those lines to be parallel, then I want those two angles to be supplementary. So let's see if those are supplementary. So I'm going to do 66 plus 114 and see if that gives me 180. Yes, they do. So I know that A and B are parallel because of the same side interior converse theorem. So see if you can do the rest of these on your own.